This is the first video in the beginning programming series for the JackBord. For more information, visit jb.works and enter the TMT code at the bottom of your screen at the search prompt. The first thing we're going to do is look at the different types of computer. And believe it or not, all of the pictures at the bottom of the screen show different types of computer. A very basic definition of a computer is something that executes a task by following a set of instructions. And the first types of computer were actually human beings. And these were people who were very good at mathematics and carried out complex mathematical calculations required by things like NASA during the 60s for the space program. And also accounting firms used them a lot to keep books. So the instructions for these human computers were the mathematical equations that they had to solve. In fact, NASA founded the West Area Computing Section in the 50s, and that was made up of human beings or human computers. So the first computers were actually human beings. The next type of computer is the mechanical computer. And the first one of these was the Jacquard loom of 1804. A loom is basically a big machine that produces textiles, so for example sheets or dress material or curtains. And the patterns that are shown on fabrics are produced by these looms. And what made the Jacquard loom special is that it used punched cards, which are these ones here, to store the pattern that would be produced on the fabric. What this meant is that one loom could by itself produce a given pattern, which allowed mass production. And this is in a way the first stored program, so you could say that the program for the loom is stored on these punched cards. And over here on the right hand side we have a modern day equivalent. This is a loom made by someone on hackaday.com that basically creates a Pikachu fabric. Following on from the Jacquard loom, something that survived from it were things called punched cards. And what these were are pieces of stiff card that could store 80 bytes of data on each of the cards. And they were used in computers from the 50s to the late 70s. So programs were basically stored as stacks of cards. And you would use a machine like this IBM punch card reader to read these stacks of cards into the computer. And this card reader shown on the right was actually bigger than a washing machine. So to give you an example of the scale, to store a modern 20 megabyte JPEG image using punched cards, you would need 250,000 of them to store one image. And this picture on the front at the bottom is a punched card, basically at full size. And you can see where the punch holes have been made in the card to represent the data. Before we move on and look at electronic computers, we need to learn about the basic switch. A switch in electronics simply brings two electrical contacts together with each other, and in so doing allows current to flow in the circuit. Most switches you see in daily life are mechanical ones like the one shown below, and this is similar to the ones on the wall of your house that you use for turning lights on and off. In this diagram, the switch is off, and this is the logic state of 0. So computers use binary logic which only has two states, 0, which is off, and 1, which is on. So in the circuit shown in the diagram, the switch is open, no current flowing, and the bulb is off. So we're at logic 0. If I close the electrical contacts, the current flows, the light turns on, and we're in logic state 1. So we have gone from logic state 0 to logic state 1. So 0, no electricity flowing, circuit's off. Logic state 1, electricity is flowing, and the light bulb turns on, and we're at logic 1. The electronic switches made in computers, especially modern computers, are made with special materials called semiconductors and are extremely small and use very little power. And given that an iPhone 15 has 15 billion transistors in it, it's good that they don't use much power, otherwise you'd have a very hot phone. They're also capable of switching on and off very, very quickly, which is why modern computers are so fast. And given that the average modern CPU has billions of electronic switches in it, they have to be very small. So looking at the bottom of the screen, this glass tube is called a valve, and it's a very early type of electronic switch. They used a lot of power and they got very hot. Next to it, we have a very early electronic transistor, and this is, again, a switch. Does exactly the same job. It's just they're a lot smaller and use a lot less power. This next type of computer is interesting because it's actually electromechanical. So it has both mechanical elements and electrical elements. And the reason it does is because it uses relays. And this, on the right-hand side, is a relay. And it's a mechanical switch that's driven with electricity. And the way it works is if you look, you've got this arm coming across. And then under here, you've got an electric magnet. So when you apply current to the magnet, it basically pulls this contact down. And as you can see, it will bring this arm down and make an electrical connection between here and the bottom pole. Right now, when it's not turned on, you can see that there's an electrical connection between this pin and here. Now these were mechanical, and this is the Facom 128A computer made in Japan in 1956, and it contained 5,000 of these relays. And believe it or not, it's still running today. If you search for that on YouTube, you'll find a video of this mechanical computer running. And basically for switches, it uses relays. And it was used to help design aircraft in Japan. And it could add two numbers in about 1/10 of 1 second, which compared to today where you've got computers that will add millions of numbers in 1 second, it was very slow. The next type of computer is the purely electronic valve computer. And the first of these was the Anatasov-Berry computer made in 1942. And these use electronic valves. And they are basically electric switches in a glass bottle. And this computer had over 300 of these valves, which you can see in the bottom here and over here as well, to do its job. And essentially it was used to solve linear equations. And it was a monster, weighing over 320 kilograms. And over here you can see some of the valves as they were installed in the computer. So each valve is basically one electric switch. The next type of computer use electronic transistors. And what these are very small, fast switches. And this is one shown on the right, shown about 5 or 6 times its normal size. And what this meant is that you could fit a lot more electronics into a much smaller place, use less power, and generate a lot less heat. And the PDP-1, which is shown here on the left, was one of the first transistor computers, and it occupied a whole room. And it basically had 2,700 transistors inside it. And they were laid out in modules like this one shown in the center. And these are the transistors in the bottom. So just keep in mind that this module contained 6 transistors. And they were about 10 centimeters wide by about 20 centimeters long. Modern day computers use things called integrated circuits. And basically an integrated circuit is a special silicon chip that can contain up to billions of electronic parts, things like resistors, diodes, and transistors. And they do this in a very tiny area. So if you look at this IC on the bottom left-hand corner, this is the Intel 4004, which was made in 1971 and was the first microprocessor. And it contained 2,300 transistors. If we then go over to the right-hand side to 2022, this is the Apple M2 CPU, and it contains 67 billion transistors. And all computers have a thing called a motherboard, and that's what this is. This is the motherboard of an Apple M2 MacBook Air. And this is the CPU in here. And these other boxes are all integrated circuits that contain millions, and in some cases billions, of transistors. So essentially, the evolution of computers has gone from human beings to mechanical computers, to electronic computers using valves, to computers using small single transistors, to where they are now, which is integrated circuits containing billions of transistors. And keep in mind that a transistor is simply a switch that is either on or off. So now that we know what a computer is, what about programming? So with your JackBord so far, you will have probably used lots of commands, and that's where you type them into the command prompt and you get a response back. And one thing you would have noticed about the command prompt is that you only have so much room in which you can type a command, and then you run out of space. And that's one of the downsides of the command prompt. So what a program does is it tells the computer what to do. So essentially all computers, human or otherwise, they need instructions for a given task. And the command line is one way of giving the computer instructions. Because if you don't, the computer will literally sit there and do nothing because they have no initiative. So if you take the case of a pug dog, for example, so the one on the left is a live pug dog, and you can give it instructions. You can tell it to do things like get the paper or get a bone or whatever. But if you don't give it any instructions, it will just go off and do something else. It has initiative. It can do other things. Whereas the pug dog on the right is a robotic pug dog made by some college students for the major production at Paraparaumu College. It can still go and do things, but you must give it instructions. So all computers need instructions, and that is the purpose of programming, is to produce the instructions that a computer needs to run. So what is a computer language? Well, a programming language is basically like a human language in that it allows us to express ideas and instructions to a computer in a way that it can understand. And each programming language has its own way of doing things, and this is called its syntax. So for example, you've got here the instructions for making a cup of tea. And you could say that the computer language is the English language and that the computer is a human being. And you have the set of instructions. One of the first things that you do when you learn computing is learn how to print the message "Hello World." And what we can see here are 5 different computer programming languages that let you print "Hello World" in 5 different ways. So the first one is C, the next one is Python, and so on. These all do exactly the same thing, but the differences are the syntax of the particular language. In the JackBord, we use a language called Octagon. And to print the message "Hello World" in Octagon, you use this method. So in this series of videos, we're going to learn more about programming using the Octagon programming language. For more information, visit jb.works.